explaining fractional distillation to you. Now, it's a very fascinating topic because growing up I was such a massive fan of cars, and then someone told me that obviously you need petrol to fuel your car, and then that petrol actually comes from crude oil. So what on earth is crude oil? It's a mixture of hydrocarbons, and essentially the downside is it is non-renewable, which means once it runs out it's gone, and it's made out of dead animals and dead plants, and it takes millions of years to actually form. So I'm thinking to myself, that's why engineers today are working so hard to look at different alternatives to the fueling stations that we have right now, the petrol and diesel and stuff like that. So actually crude oil is actually fascinating because it's got lots of different things inside it. It's a mixture, and the way we're going to separate that mixture is by using fractional distillation. Okay, but before we talk about that, let's talk about why crude oil is so important, because it is so important. So pause the video, have a go, see if you can list some reasons on why crude oil is so important. Okay, now crude oil, and not just petrol, believe it or not, it's more than just that. Petrol and diesel is actually aircraft, ships, heating and power stations, raw materials, petrochemical industries. There's a load of people and industries relying on crude oil. So crude oil is actually very, very important. Now, how do they separate it? Now, it's fascinating because obviously if you got, it's like I was doing an experiment with water. I had water and acetone. Now acetone, if I'm right in saying, I mixed them up. Now acetone has a boiling point of 56. So when I was heating that up, that vaporized, and I collect that in using fractional distillation. Simple distillation, you could just collect it, and the water will stay behind because water's got 100 degrees temperature. It boils at that. This is what's happening. You're boiling them up, but there's about 8-9 different things inside. So they're all gonna come out according to their boiling point. The shorter ones, you'll see at the top, the shorter hydrocarbons, and the longer hydrocarbons with a bigger boiling point or a larger boiling point would be towards at the bottom. So it's important to understand that heating them up, there's about 8-9 different things in there. They're going to heat up, and once they reach their boiling point, they're going to vaporize, and they're going to condense and cool off, and they're going to be collected in their different fractionating columns. Okay, it's very important that you understand. Now I wrote all that stuff down for you because there are some exam questions that could come your way, like this exam question. You know, state the name of the fraction labeled X. They could ask you other questions as well, like the one over there. I'm really sorry, I've just got to state the property of the fractions that allow them to be separated by fractional distillation. So pause the video, have a go at these questions. Okay, so the first one would be bitumen, and the one lower than that is because they've got different temperatures. That's how they are separated. They have different boiling points. Now look at this question, have a go at this. Draw a line from the correct label to the correct what the use. So what's petrol used for? Why is kerosene used for? Have a go. So I told you this is why fractional distillation is so important. So petrol used for cars, kerosene for fuels for jet, aircraft, stuff like that. So it's very important to understand fractional distillation and crude oil. Thank you very much for watching this video. Please like and subscribe.